Hey guys, so in this video we are going to talk about second order non-homogeneous linear ordinary differential equations. On our previous video, homogeneous yung diniscuss natin. Okay? So dito naman, non-homogeneous linear ordinary differential equations. So in this video, we are going to discuss two methods that we can use in order to solve second order non-homogeneous linear ODEs. First, let us consider the second order non-homogeneous linear ODE. So when written in standard form, it will look like this. So we have y double prime plus p of x y prime plus q of x y equal to r of x. Again, this is a non-homogeneous ordinary differential equation. Therefore, yung r of x natin dito, okay, so yung right side ng equation natin, that will not be equal to 0. So for these types of ODEs, the general solution is the sum of a general solution of the corresponding homogeneous ODE and a particular solution of our non-homogeneous ODE. So yung general solution again ng non-homogeneous linear ODE will be of this form. So we will have y of x equal to y sub h of x plus y sub p of x. Okay? So yung general solution natin dito, merong dalawang parts. So yung first part natin dito or yung first term, which is the y sub h, that is the general solution of the corresponding homogeneous ordinary differential equation. So if we are given a non-homogeneous ODE, yung gagawin lang natin is we will simply equate this to 0. So magiging homogeneous na siya. Again, yung first term will be the general solution of this corresponding homogeneous linear ODE. So tandaan nyo lang, y sub h. So the h stands for homogeneous ODE. And itong second term naman natin, y sub p, is any solution of our non-homogeneous linear ODE containing no arbitrary constants. So hopefully, yung pagkuha ng first term ng general solution natin dito, yung y sub h, which is the solution again of the corresponding homogeneous ODE. So na-discuss na natin yan on our previous video. So yung problema na lang natin dito is paano natin hahanapin itong second term natin, yung y sub p. So again, in this video, we are going to discuss two methods in order to obtain the value of this solution. The first method is the method of undetermined coefficients. So the solution y sub p of our non-homogeneous linear ODE can be obtained using this method. More precisely, this method is suitable for linear ordinary differential equations with constant coefficients a and b. So that will be equations of this form, y double prime plus ay prime plus by equal to r of x. Again, a and b here are constants, pero yung r of x natin is not equal to 0. This method will be very useful in cases where our r of x is an exponential function, a power of x, a cosine or sine, or sum or products of these functions. So, kahit combination ng mga functions na to. Now, these functions are special because their derivatives have a form similar to r of x itself. Okay, so for example, let us take the derivative of an exponential function e raised to x. So, yung derivative na to will be e raised to x dx. So, as you can see, similar lang ng form yung dalawa. Okay? Now, this idea leads to the following method. So, yung gagawin natin is we will choose a form for y sub p similar to r of x, but with unknown coefficients to be determined. Kaya nga yung tawag sa method na to is undetermined coefficients. Okay? So, again, we will choose a form for y sub p similar to our r of x, but with unknown coefficients to be determined by substituting that y sub p and its derivatives into our non-homogeneous ODE. So this table shows the choice of y sub p for practically important forms of r of x. here in our first row, if our r of x contains the term k times e raised to gamma of x, so yung magiging choice for y sub p natin will be c e raised to gamma of x. Again, k and c here are constants. So, etong c na to sa y sub p natin, we can determine the value of this by simply substituting again yung y sub p natin into our ODE. So, mamaya ipapakita natin yan sa mga examples natin. Now, dito naman sa second row, if yung r of x natin contains a term which is a power of x, so k times x raised to n, where n is any power, so we have 0, 1, 2, up to n. So, yung magiging choice for y sub p natin will be of this form then. Okay? And if our r of x contains the trigonometric terms cosine or sine, so ito naman yung magiging choice for our y sub p. And then lastly, if our r of x contains terms that has this form, then ito naman yung magiging choice natin for our y sub p. Now, there are certain rules that we need to remember or we need to follow when using this table. Okay, so the first is what we call the basic rule, second, modification rule, and the third is yung sum rule. So we will explain and illustrate each of these rules in the following examples. So for our first example here, solve the initial value problem y double prime plus y equal to 0.001x squared given the conditions y of 0 equal to 0 and y prime of 0 equal to 1.5. So first, let us recall na yung general solution ng non-homogeneous linear ODE natin will be equal to y sub h plus y sub p. So first, kunin muna natin yung y sub h, which is again the general solution of the corresponding homogeneous ODE. So for this example, yung magiging corresponding homogeneous equation natin will be y double prime plus y equal to 0. So to get the corresponding homogeneous ODE, yung gagawin mo lang is i-equate lang natin yung r of x or yung right side ng equation natin into 0. So in order to obtain the general solution of this homogeneous equation, babalik lang tayo doon sa previous method na diniscuss natin on our previous video. First, kukunin muna natin yung auxiliary equation natin. So that will be lambda squared plus 1 equal to 0. Okay? So this will fall under case 3. So we will have imaginary roots for our auxiliary equation. Therefore, yung general solution ng homogeneous ODE natin ngayon will be equal to a cosine of x plus b sine of x. Okay, so nakuha na natin yung first term ng general solution ng non-homogeneous ODE natin. So ngayon naman, let us move on to our second term, y sub p. Kung mapapansin nyo, yung r of x natin has a term that contains a power of x. Therefore, the method of undetermined coefficients will be very useful in this case. So, titingnan lang natin ulit yung table. Makikita natin dito sa second row, ito yung form ng r of x ng given non-homogeneous ODE natin. Therefore, yung magiging choice for our y sub p will be ito din. So, ito yung first rule natin when using this table, okay? So, yung basic rule. So, basically, if r of x contains a function that is in the first column, then we will simply choose y sub p in the same line and then determine its undetermined coefficients by substituting y sub p and its derivatives into our non-homogeneous linear ODE. So, in this case, yung n natin is yung power ng x, so that will be equal to 2. Therefore, our choice equation for y sub p will be equal to k sub 2 x squared plus k sub 1x plus k sub 0. Okay, so next is we are going to determine the value of these coefficients. So, kukunin natin yung value ng k sub 2, k sub 1, and k sub 0. Now, in order to do this, yung gagawin lang natin is we will simply substitute this equation and its derivatives into our non-homogeneous ODE. So, substituting the value of y double prime and y into our ODE and then combining like terms, we will have this equation. Now, yung next na gagawin naman natin is we will equate the coefficients of x squared, x, and then x raised to 0 on both sides of our equation here. So, dito sa right side ng equation natin, makikita natin na we only have a value for our x squared na term. So, yung pwede natin gawin is we will simply add 0x plus 0 dito sa right side. Okay? So, para makita lang natin and makompare natin ng maayos yung mga coefficients natin. So, first, let us compare the coefficients of x squared on both sides of our equation here. So, sa left side, yung coefficient ng x squared na term is k sub 2. And then sa right side naman, yung coefficient niya that is 0.001. Therefore, k sub 2 should be equal to 0.001. Next naman is yung coefficients ng x na term. So, on the left side, we have k sub 1. And then, on the right side, we can see that the coefficient of x here is equal to 0. Therefore, we will have k sub 1 equal to 0. And then, lastly, for the coefficients of x raised to 0, so basically, that is equal to 1, no? X raised to 0. So, we will have 2k sub 2 plus k sub 0 for our left side. And then on the right side of our equation naman, we will have 0. Now, if we substitute the value of k sub 2 here, makukuha natin yung value ng k sub 0 natin. So, that will be equal to negative 0.002. So, ngayon, we will simply substitute these values dun sa y sub p equation natin. So, for our y sub p here, this will now be equal to, okay, so yung k sub 2 that is equal to 0.001. Yung k sub 1 naman natin that will be equal to 0. And then k sub 0 again natin that will be equal to negative 0.002. So now we have y sub p equal to 0.001x squared minus 0.002. Okay, so finally, we have the value for the two terms of our general solution. Okay, so we will simply add these two solutions. So now we have the general solution, y equal to a cosine of x plus b sine of x plus 0.001x squared minus 0.002. Okay, pero hindi pa ito yung final answer natin because we have an initial value problem here. So we still need to obtain the value of these constants a and b. So, in order to obtain the value of these constants, gagamitin lang natin yung conditions na binigay sa problem. So, using the first condition, y of 0 equal to 0, we will simply substitute x equal to 0 and then y equal to 0 here in our general solution. So, after we simplify, we will obtain the value of our first constant a, and that will be equal to 0.002. And then for our second condition naman, so we need to take the derivative of our general solution first before we can work with this condition. So yung y prime natin, that will be equal to negative a sine of x plus b cosine of x plus 0.002x. So again, we will simply substitute the given condition here. So y prime natin, that will be equal to 1.5, and then yung x naman, that will be equal to 0. So after we simplify this, we will obtain the value of our second constant b equal to 1.5. Okay, so ngayon, ito na yung magiging value ng particular solution natin. So we will simply substitute the value of a and b here. So now we have y equal to 0.002 cosine of x plus 1.5 sine of x plus 0.001x squared minus 0.002. So, ito na ngayon yung particular solution doon sa initial value problem natin. So, next, let us move on to our second example. determine the general solution of y double prime plus 3y prime plus 2.25y equal to negative 10 e raised to negative 1.5x. So again, yung general solution natin will be of this form, y equal to y sub h plus y sub p. So first na kukunin natin will be yung y sub h. That will be the general solution of the corresponding homogeneous ODE. So in our problem here, the corresponding homogeneous ODE will be y double prime plus 3y prime plus 2.25y equal to 0. So in order to obtain the general solution of this homogeneous equation, so makikita natin that this has constant coefficients, okay? So we can solve this equation by first obtaining the auxiliary equation. So our auxiliary equation here will be lambda squared plus 3 lambda plus 2.25 equal to 0. Now if we examine the roots of our auxiliary equation, so makikita natin that this will fall under case 2. Okay, so we will have double roots. Hence, the general solution of our equation will be y sub h equal to e raised to negative 1.5x times c sub 1 plus c sub 2x. After that, next naman na kukunin natin will be yung value ng y sub p. So as we can see, yung r of x natin na term has a form similar to the first entry in our table here. Okay, so yung first row, since this is an exponential function. So yung choice for y sub p natin will be equal to c times e raised to negative 1.5x. Pero kung mapapansin nyo, itong y sub p natin is also a solution to our homogeneous ODE. Okay? So dito sa y sub h natin, so ito, bali e raised to negative 1.5x times c1. So ito din yung y sub p natin. In this case, hindi natin pwedeng gamitan agad-agad itong y sub p na nakuha natin sa table. We need to apply the second rule. Okay? So yung modification rule. So yung gagawin natin is we will modify our y sub p. So the modification rule states that if a term in our choice for y sub p happens to be a solution for the homogeneous ODE, then we will need to multiply this term by x or by x squared if the solution corresponds to a double root of the auxiliary equation of the homogeneous ODE. So in this case, kasi we have a double root, diba, for our auxiliary equation, so we need to multiply x squared to our y sub p. Again, sabi dun sa modification rule natin, we need to multiply either x or x squared. So x squared kapag double root, and if yung auxiliary equation natin does not have a double root, then we will simply need to multiply x. Now we have y sub p equal to c times x squared e raised to negative 1.5 of x. So in order to determine the value of our coefficient c in our y sub p, we will simply substitute this equation and its derivatives into our given non-homogeneous ODE. So substituting the values of y double prime, y prime, and y into our ODE here, so we can actually eliminate e raised to negative 1.5x on both sides of our equation here. And then after combining like terms, we now have this equation. So again, yung gagawin natin is we will simply compare the coefficients of x squared, x, and then x raised to 0 on both sides of our equation. But if we simplify further the terms inside our parentheses here, we can see that this will be equal to 0. Ito din magiging 0. Therefore, we are only left with 2c equal to negative 10. So this will give us the value of our coefficient c equal to negative 5. So ngayon, yung value ng c natin dito will be negative 5. So ito na yung value ng y sub p natin. And then finally, we can now obtain the general solution of our ODE. So again, y, that will be equal to y sub h. So that is e raised to negative 1.5x times c sub 1 plus c sub 2x. And then plus yung y sub p naman natin. So that will be negative 5x squared e raised to negative 1.5x. Now, you may be tempted to simplify this solution further. So, baka i-combine nyo pa yung mga terms dito. Okay then, pero I suggest that you leave it at this form na. Okay, so para madali lang natin makita kung ano yung y sub h and then yung y sub p na terms natin. Okay? Okay. So, now let us move on to our next example. So, for our third example, determine the general solution of y double prime plus 2y prime plus 0.75y equal to 2 cosine of x minus 0.25 sine of x plus 0.09x. Again, first na gagawin natin is we will obtain the value of our y sub h. Kasi yun yung mas madaling kunin. Okay? So the corresponding homogeneous ODE of our equation here will be y double prime plus 2y prime plus 0.75y equal to 0. And then from this homogeneous ODE, yung auxiliary equation naman natin will be lambda squared plus 2 lambda plus 0.75 equal to 0. Now examining the roots of this auxiliary equation, we can see that this will fall under case 1. Hence, the general solution of this equation will be y sub h equal to c sub 1 e raised to negative x over 2 plus c sub 2 e raised to negative 3x over 2. So, ngayon naman, yung y sub p, yung hahanapin natin. So, as you can see, our r of x contains several terms. So, based dun sa table natin, we can see that our r of x is a sum of functions that are in the first column of our table. In this case, we will apply the third rule, so yung sum rule. So the sum rule states that if our r of x is a sum of functions in the first column, then we will choose for y sub p the sum of the functions in the corresponding lines of the second column. So since our r of x here is a sum of terms containing the cosine and sine function and then a term containing a power of x, so yung 0.009x, we need to apply the sum rule. So yung y sub p natin, so this will be equal to y sub p1 plus y sub p2, where our y sub p1 will be equal to the choice equation for our y sub p based doon sa cosine and sine na terms. So this will be k times cosine of x plus m sine of x. And then yung y sub p2 naman natin will be the choice equation based on the 0.09x na term. So that will be on the second row. So yung value ng n natin dito will be equal to 1. Therefore, this will be equal to k sub 1x plus k sub 0. Okay, so we need to determine the value of these coefficients. So meron tayong 4 na undetermined coefficients here. Again, yung gagawin natin is we will simply substitute this equation back into our non-homogeneous ODE. And then, we will simply compare the coefficients on the left side and the right side of the resulting equation. So, yung gagawin natin dito is we will substitute this one by one para hindi tayo mahirapan. First, we will take y sub p1. We will substitute this and yung corresponding derivatives niya into our ODE. And then after simplifying and combining like terms, bali yung gagawin natin is we will compare the coefficients of the cosine and sine na terms. So sa left side ng equation natin, we can see na yung coefficients ng cosine of x na term is negative k plus 2m plus 0.75k. And then sa right side naman, yung coefficient ng cosine natin is 2. So, simplifying the coefficients of the cosine x na term sa left side, we will have 2m minus 0.25k and this will be equal to 2. Then similarly, yun din yung gagawin natin doon sa sine of x na term. So, simplifying the coefficients of sine of x on the left side of our equation. So, that will be equal to negative 0.25m minus 2k. And then, this will be equal to the coefficient of sine of x doon sa right side naman ng equation natin. So, that will be negative 0.25. Now, using these two equations, we can now obtain the value of our coefficients m and k. So, m, that will be equal to 1, and then yung k naman natin will be equal to 0. And if we substitute this back into our y sub p1, yung value na ngayon ng y sub p1 natin will be equal to sine of x. Next naman is hanapin natin yung value ng coefficients k sub 1 and k sub 0. So same lang dun sa ginawa natin kanina, we will take our equation y sub p2 and then substitute this and its corresponding derivatives into our non-homogeneous ODE. Combine like terms, and then compare the value of our coefficients. So comparing the coefficients of x on both sides of our equation, we will have 0.75 k sub 1 on the left side. So yan yung coefficient ng x natin. And then on the right side naman, yung coefficient ng x is 0.09. So i-equate lang natin yung dalawa. And then for our x raised to 0 or 1 na term, on the left side we have 2 times k sub 1 plus 0.75 k sub 0. And then on the right side naman, that will be equal to 0. So again, using these two equations, we can obtain the value of our coefficients k sub 1 and then k sub 0. So k sub 1, that will be equal to 0.12, and then k sub 0 equal to negative 0.32. And then, taking these values, isa-substitute lang natin doon sa y sub p2 na equation natin. So now we have y sub p2 equal to 0.12x minus 0.32. Therefore, the value of our y sub p will be equal to sine of x plus 0.12x minus 0.32. And then, now, we will simply add the value of y sub h and y sub p in order to obtain the general solution of our non-homogeneous ODE. So that will be y equal to c sub 1 e raised to negative x over 2 plus c sub 2 e raised to negative 3x over 2 plus yung y sub p. So that is sine of x plus 0.12x minus 0.32. Again, kung hindi kayo sure doon sa nakuha nyong sagot, you can simply verify your answers by substituting your solution or yung nakuha nyo na equation doon sa original ODE nyo. And then, tingnan nyo lang kung nasatisfy ba siya. Okay, so that's it for our first method. So next method naman na pag-uusapan natin will be the method of variation of parameters. So this method will be more general, okay? So, compared doon sa previous method natin, we were only able to apply the method of undetermined coefficients for certain values of r of x. So, for values of r of x that are not too complicated. So, ngayon naman, itong method of variation of parameters will be applicable for more general ODEs. So, for the non-homogeneous linear ODE, written in standard form, y double prime plus p of xy prime plus q of xy equal to r of x, where p, q, and r may be variables, so they are not constants. So this method of variation of parameters will give a solution, a particular solution y sub p equal to negative y sub 1 times the integral of y sub 2 times r over w dx plus y sub 2 times the integral of y sub 1 times r over w dx. Now, this solution formula is obtained under the assumption that the ODE is written in standard form. Okay? So, kung hindi nakasulat sa standard form yung given equation, then you first need to rewrite it into its standard form before you can apply this formula. So, isa-isahin natin yung mga variables dito sa formula natin. So, yung r, yan yung right side ng non-homogeneous equation natin. And then, itong y sub 1 and y sub 2 naman will form a basis of solutions for the corresponding homogeneous ODE. So again, yung corresponding homogeneous ODE natin will be of the form y double prime plus p of x y prime plus q of x y equal to 0. And then, yung value naman ng denominator natin, so yung w, that will be equal to y sub 1 times y sub 2 prime minus y sub 2 times y sub 1 prime. Okay, so let's try to apply this method in this example. Solve y double prime minus 4y prime plus 4y equal to x plus 1 times e raised to 2x. Again, first thing na gagawin natin is hanapin natin yung value ng y sub h. So the auxiliary equation based on the corresponding homogeneous equation will be lambda squared minus 4 lambda plus 4 equal to 0. Now, if we examine the roots of this auxiliary equation, makikita natin that this will fall under case 2. Double roots siya. So now we have the value for our y sub h, and that will be equal to e raised to 2x times c sub 1 plus c sub 2 times x. Again, hindi na natin nire-write yung equation natin into its standard form kasi yung given equation naman is already in its standard form. So from our equation, yung value ng r of x natin will be x plus 1 times e raised to 2x. Now, yung gagawin natin is we will apply the method of variation of parameters. So, galing dun sa formula for our y sub p, again, yung value ng y sub 1 and y sub 2 dito will be the basis of solution for our corresponding homogeneous ODE. Madali na lang to kasi kinuha na natin yung solution ng equation na to kanina. Okay? So, for our y sub 1, this will be equal to e raised to 2x. And then for y sub 2 naman, this will be equal to x times e raised to 2x. Next is we will obtain the value of our variable w here. Again, w will be equal to y sub 1 times y sub 2 prime minus y sub 2 times y sub 1 prime. So, galing doon sa y sub 1 and y sub 2 natin kanina, we will simply substitute these equations and then yung derivatives nila dito. And then if we simplify this, we will obtain the value of our w, which is equal to e raised to 4x. So, ngayon, isa-substitute lang natin to lahat dito sa formula natin for our y sub p. After evaluating our integrals here and then simplifying further, we now have the value for our y sub p equal to 1 over 6 x cubed e raised to 2x plus 1 half x squared e raised to 2x. And then substituting this to our general solution, we now have y equal to yung y sub h natin. So that will be e raised to 2x times c sub 1 plus c sub 2x plus yung y sub p natin. And now, we have this general solution. Again, you may be tempted to simplify this further, no? Kasi meron tayong mga common factors dito. So, I suggest na ito na, okay na to, no? Huwag nyo nang i-simplify pa para makita natin kung ano yung y sub h and then yung y sub p na functions natin. Okay, so that's it for this video, guys. So, hopefully, meron kayong natutunang bago. So, see you on the next one.